we're told that we work on a dairy farm here, and we want to make sure that eggs that have boxes that have broken eggs don't go out. So 25% of the time, a box will have some number of broken eggs. This is not really important because really we will qualify a box as being a broken box if it has a broken egg. It will be not a broken box if it doesn't have any broken eggs. So it's as simple as that. You either are a broken box or you're not. We're not keeping track of the count of the number of eggs because it's bad whether you have 1 or you have 10 broken eggs. The customer isn't going to want it. So suppose that 4 boxes of eggs are being shipped out. What is the expected number of boxes with broken eggs that this vendor should receive? So our random variable is x, the number of broken boxes. Well, what values can this variable take on? Well, the values can be, in the 4 there are no broken boxes, in the 4 there's 1, 2, 3, or potentially all 4 of them are broken. There might not be a big likelihood or probability, but these are the possible outcomes. Nothing else can happen. Either 0 or broken all the way up to 4, but none in between. So what I've done here is I've looked at every single combination, I guess these are permutations really, of all the different box orderings that can come. So I just started with the first box. The first box can be broken or not broken. The second box can then be broken also or not broken if the first one is. And so every chain or every step of the way, a box can either be broken or not broken. So if we follow the chain, I drew these little arrows so they're easier to follow. So to get this arrow, that'd be B, 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 B. To get this next arrow, B, 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 N. To get this arrow, B, B, N, B, 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 N, N. So I'll spare you the reading of all of these, but that would be how I would go about doing them. Okay, so each of these has a different probability. These are all AND rules. If you get B, 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 that's broken and broken and broken and broken. Okay, so what's the probability that none of them are broken? Well, that means they're all not broken, which would only be this instance right here. There's only one situation where they're all not broken. Okay, well, what's the probability of this? Well, each of these has a 75% chance of not being broken. So 0.75 times 0.75 times 0.75, because they're all independent of one another, would just basically be 0.75 to the 4th. 0.75 to the 4th power, which gives us a probability of about 0.316. Okay, now where are all the instances where 1 is broken? It's important to not just assume that the probability is just 0.25 times 0.75 times 0.75 times 0.75, because we have to count the actual number of ways. So where are there situations where only 1 is broken? Well, as I'm skimming through here, there's one. Where's another one? There's another one. And let's see, another broken one. That's another situation where 1's broken, and that's another situation where 1's broken. So there are 4 of these. Now each of these will have the same probability because they'll all be 0.25 times 0.75 times 0.75 times 0.75. They're just in different orders, but it doesn't matter whether you do 0.25, 0.75, 0.75, 0.75, or 0.75, 0.25, 0.75, 0.75, as long as there's one multiple and 3 of these multiples. Well, they occur 4 times, and each of those will have the same probability. So 0.25 times 0.75 raised to the 3rd power will give me 0.105. Because I have 4 of those replicates that will have the same probability, my overall probability will be 4 times that. So really, you could just add them together 4 times, but multiplication does that for us. So there would be a 0.42, or a 42% chance of observing 1. Well, we still have some counting to do. Of course, a very tedious job. Now we need to count situations where there are exactly 2 broken eggs. So now it has to be exactly, it can't be 2 or more. We're looking for exactly 2 broken eggs. There's another one, there's another one, there's another one, there's another one, and there's another one. That's 1, 2, 3, 4, 5, 6. So since these all 6 should have the same probability, I can pick any one. The